Hello guys, my name is Anilva John Butter. My relation number is QRK24A1106. Today I am going to explain experiment number 4, processing logs by Amazing EMR in my data engineering process and tools laboratory. So our aim is to implement a big data processing workflow using EMR by creating EMR cluster, processing log using Cloud9 portal, and perform data transformations and joins and analyzing the results using SQL-like queries. So, firstly, the Apache Hadoop is an open source framework used for distributed storage and processing of large datasets. Amazon EMR simplifies running Hadoop and related tools like Hive on a scalable clusters in cloud. So, in this lab, as a proof of concept, was developed to analyze weblog data stored in Amazon S3. Two types of log we will be using. One is impression logs as displayed and click logs as clicked. Using Hive, we will be using this log, by structuring these log into tables and processing using SQL-like queries. So Hive translates queries into jobs managed by Apache Yarn, enabling distributed data processing. So data was stored in HDFS and S3, and final outputs were returned to back to S3 buckets. So the lab demonstrated how large-scale log data can be processed efficiently to identify trends such as which advertisement leads to clicks. So like for example, if you see any ad, we'll be clicking it more. So we'll be logging the data using this EMR and S3 Apache. So first we will be launching our EMR cluster. So in this task, we'll be clustering. Open a cluster in EMR name Hive EMR cluster using AWS Management Console with Hadoop and Hive installed. The instant types and nodes on configuration were set. So here we can see I opened my cluster. My cluster name is given here. I've got the summary of it, and I've got cluster ID, cluster ARN, and the status is starting, and I have my cluster Hive EMR cluster has been successfully created. And next is task 2 is connecting to cluster using SSH. So we will be adding some inbound rules, SSH, and you will be keeping the comment like we have to connect only IPv4 config. So SSH connection was established from Cloud9 to EMR main node using a keypad. So here we can see it is installed, and we have another inbound rules. And here I saw the main node code node is running properly. And next task is we'll be using the Cloud9 terminal for it. So Hive was configured and launched into interactive mode. So we have to download the lab user PEM from AWS details to we have to upload it here. So we can see the lab user PEM here. With that, we will be using this Hive CLI. So it is successfully started enabling execution of SQLi query. So it is a result of all the comments. So it says that the Hive client is connected and we can use SQLi queries on other methods. And next task 4 is creating tables from log data. So here we can see I'm just given many types of tables like in-person tables and external table. I'm giving this table. So these are the code which still see here. I'm going to create this term called clips. So this is an example of creating a table and task based joining this table. So we have different type of table like external table, ads table, and expression table. So these tables are joined for a better like these are joined as a name called joined impressions was creating by performing left outer join between impressions and clicks data set. So the combination will be given here. And next one is querying the data. For querying the data, we'll be using this queries like to get a meaningful insights and demonstrate effectiveness of Hive for loss research. So this I have given one comment and it's fully given what are the clicks, what are the clicks which to which ad. So to save this. And next is I'm going to store the output in Amazon S3. So after that, we'll be storing all our findings in a S3 data. So for storing in S3, we will be using just I've named my files example.log. So example.log.text. This file will be processed and join data was stored in S3 bucket in sequence file format for further use. So data was fully stored in S3, enabling persistent storage and future analysis. And I got 35 to 35 in this task. Thank you.